This is the Anvil table that I built to put my anvil on that my buddy gave me. If you want to see how I built it, stay tuned. I got the finish fixed on this chest of drawers like I said I would. Sanded down this railing on my deck that I installed a couple of weeks ago and applied varnish to it like I said I would. I built this thing for absolutely no reason. Heck, I even finished the trim and the wall from installing the air conditioner like I said I would. So why haven't I built a stand for this anvil like I said I would? That's a good question. Let's do that today. Good morning. Welcome to another Memphis Monday. I think I might have been a little hard on myself in the introduction. Actually, the reason I haven't built a stand for the anvil is because I haven't decided exactly what I wanted. But I think I have now. I built a little model here. It's going to have 4x4 legs. It's going to be the same height as my other workbenches, and it's going to have wheels and so forth. So let me show you a little drawing of it. First thing we'll do, I'll show you a little drawing here and show you the concept. So this is a 4:1 scale sketch of the project. This is the anvil. It's 14 inches square and 5 inches deep. I'm going to laminate two pieces of plywood together. This is going to be an 18 square piece of plywood. These legs will angle at 10 degrees, and the outer edge of the angle will begin at right at the edge of where the anvil is going to be sitting, and then they'll be angled 10 degrees. To be reinforced with 1x material set right underneath the plywood and at halfway, and they will be set into dados. And then at the bottom there'll be a 2x4 across the ends, and some wheels that will set the thing up. I got here's the wheels I'm using. They're rated for about 150 pounds a piece, and they will set the thing up 3 1/4 inches. So the full rise of this thing from the floor to the top here will be 38 inches, which is what all my outfeed tables and other tables are. Okay, so the first thing I'm going to do is laminate together a couple of pieces of plywood, 3/4 inch plywood, to give me a top that's 1.5 inches thick. Two pieces of 3/4 inch plywood laminated together. Must be about the strongest, most indestructible thing you'll ever find. It has about 20 layers of wood, all laid crossways. All right, let's get this glued up and get to work on the legs. Okay, back over the prototype here, you can see that the legs angle out 10 degrees. And if that's all that happened, that would be easy peasy, but it's not. If you turn it the other way, they angle this way also, which puts a compound angle up here and down here. Now that just means you need to set your miter saw at 10 degrees and your tilt at 10 degrees and cut these angles, these compound angles. And so it sounds simple, except it's very difficult to get those angles to happen at exactly the right place on the wood, so that all the legs are the same length. So let me show you a trick that I learned some darn where I didn't invent it. How you can do those compound angles a little simpler. Okay, here's how it works. Instead of cutting a compound angle using the tilt and the angle down here, I just set the leg, the 4x4, up on these little jigs here, which are little blocks of wood with 45-degree angles cut in them, which then presents the piece rotated 90 degrees, and then the saw is just tilted back 10 degrees, and then that puts that perfect compound angle on that leg. And then I know that from that point right there to the next cut is 27¼ degrees. So I'll let you watch me make that cut. So now you can see if the corner of this workbench were the place I wanted to place the leg, I just square it up right on there, and you can see that I got a 10-degree angle this way and a 10-degree angle that way, and it fits perfect. Next operation is to cut the slots in the legs for these braces to fit in. Let me show you what that's going to look like. Here is what the joint's going to look like. I'm going to cut a slot of dado that is 2½ inches wide and 11/16 inch deep on each one of the legs here. Now I'm tempted to just set these legs at the right angle, lay a piece of this 1x material and make it parallel to the level, and just cut the lines and mark the lines. But if I did that, mistakes would creep in, and I don't want that to happen. So let me show you what I'm going to do. So instead of marking those dados where I'm going to put the dados, I toenailed the legs right to the lid so that I could set it up, and I could check all the angles, make sure everything sits straight, and then I can mark where I'm going to put the dados exactly without error. So put them in dark ink so that because I'll be cutting them on my stacked dado head cutter, which is next. I got the notches in the legs all done. What I'm doing now is adding the braces. As I fit the braces, I'm just shooting a couple of finish nails in it to hold it together until I put the screws in. Yeah, I'm going to hold this thing together with finish nails, you know, just temporarily. That way, every time I make a minor adjustment, I have to completely disassemble the thing and pull all the nails out. Did you ever notice that a good idea always goes from a good idea to a bad idea? Never goes to an average idea or an adequate idea or a so-so idea? Nope. It goes directly from good idea to a bad idea. Of course, I'm using clamps now to temporarily hold the thing together, which is what I should have been using all along. Well, I got everything lined up. Now it's just a matter of screwing in 64 exterior deck screws. Let me get this done and I'll show you how I plan to put the interior bracing between the legs. Over here on the prototype, you can see that in addition to the bracing here and here and the leg braces up here, I've included filler strips between the legs, between the gaps of the legs. These on the piece will consist of a 2x4 cut with a 5-degree angle here and a 5-degree angle here. Actually, it's called a 2x4, but really that's just a little bit less than 3 inches across there. And on top of that will be another board cut with the 5 degrees here, 5 degrees here. Let's go over on the piece and see what I'm talking about. Here's over on the piece. I've already got the 2x4 section installed down here. Now, in addition to the 5-degree angles on the board, there's also a 5-degree angle at both ends of the spacers. So this spacer will then go in on top of here, and that will bring the whole thing up even with the trim. And these legs then will be down in these 2.5-inch long holes. Well, I'm about ready to put the wheels on it, but I wanted you to see these this internal bracing. You see that each leg is held in place by, is actually sitting down in about a 3-inch cavity. Those little screws, those are long screws right there that angle into it. And then the bracing on the outside is screwed through to the block on the inside. So this thing is pretty much indestructible. Okay, let's put the wheels on it. I'm attaching the bottom wheel braces using these power-coated newfangled lag bolts. And I'm holding the wheels on with these old school zinc coated small lag screws. got all the wheels on. They set up about 3 1/4 inches, and each one has a little locking tab, so I can lock all 4 wheels. Okay, let's flip it over on its wheels and put the trim on it. I'm putting trim all the way around the piece. It's will keep anything on the top from falling off, and since it serves a purpose other than just looking good, I'm gluing it and nailing it. Well, there it is, but we're not through yet. We got to put that anvil on top of it now. So that's what we're going to do next. Okay, here's what you paid your money to see. I don't plan on getting anywhere near close to this thing. Okay, now I'm going to release a little pressure. And get that thing leaned over towards me. Now move the back a little bit. I think we deserve a drum roll, don't you? Well, I guess that does it for another Memphis Monday. This project had a little bit of everything, a little shop work. I'm happy to say that remember our plan called for it to come out exactly level with our other work tables, and it is. I'm crossed my mind, might have overbuilt it a little bit, but then I got to thinking that you probably can't overbuild a table that is meant to carry a vise. I mean, an anvil. Usually anvils sit on tree stumps, you know, some really heavy, big stuff, but I wanted to be able to move it around. But we had, today we had design work, we had prototypes, we had building, we had trimming, whole works. So see you next week. Don't forget about me. And don't forget to comment.